Hello, welcome to software testing methodology. So today I am going to discuss the topic about the application which performs in reduction algorithm. What is the main use of these applications? There are some of the applications to be used in node reduction algorithm. So it consists of common pattern and common procedure that are to be followed. What we have to follow, and the node reduction removal algorithm have several applications. For every application, a common pattern or common procedure be followed. So what is the common pattern? So first, each and every graph should be converted into path expression. First, there is a flow graph. Then that each and every flow graph can be converted into path expression by using the node reduction algorithm. Like what I told before videos in the node reduction algorithm, we have to achieve the path expression between entry node and exit node. So that is the first step as a common pattern and common procedure to be followed in application. Second one is the set of arithmetic rules must be derived. So there are some of the set of rules which is to be derived for the selected property of the path. So follow that rules. The first one is nothing but converting the graph into path expression, and second one is nothing but set of arithmetic rules must be derived for the selected property of the path. So third one is the link name should be replaced by link weights. So all the link names should be replaced. So wherever the link representation can be defined between node to node, that link names can be replaced, such that we can define that is the third common procedure. So fourth one is so that the path expression will be converted into some algebraic expression. So that is the fourth step. So these are all the common pattern and common procedure to be followed. Whenever the node reduction algorithm have several applications, when we use that application, when we derive that application, we have to follow this common pattern and common procedure. So next, what is the list of applications there? So there are 6 list of applications. The first one is maximum path count, second one is structured, third one is lower path count arithmetic, fourth one is probability of being at a certain point, fifth one is mean processing time of a routine, and last one is push or pop and get or return. So these are all the 6 list of applications used to perform the reduction of algorithms, node reduction algorithms. So this is nothing but 6 type of applications. So first we'll see about the first application is maximum path count. The name itself defines the maximum number of paths to be achieved. So whenever the arithmetic rules to be followed, then what is the maximum path count to be achieved? We can perform as maximum path count arithmetic. So that the most important application of node removal algorithm is to find the maximum number of paths in the graph. So for this, each and every link in the graph has to be assigned a weight. So wait, and at loops it has to be numbered with the digit, which gives the maximum number of times the loop can be taken. So you can take any maximum like 3 or 4 or 5. So the another way to define a maximum path count arithmetic means if the count of the loop is infinite, then the maximum path count would be infinite and the process can be stopped. So have to follow the some arithmetic rules to define the maximum path count. I will show you the example how the maximum count will be defined. So what is the arithmetic rule? There are 3 arithmetic rules that are to be followed in reduction, or parallel rule, series rule, loop rule. So these are all the 3 common rules in every application will be defined, but there is some of the like weights can be changes, some of the variables can be changes, but rules are same different for every application. The values that should be considered in case of series, parallel and loop cases are, so this is the values. So in the maximum path count arithmetic, path expressions parallel rule is a plus b, series rule is ab, and loop rule is a power n. This is the path expression. This is for maximum path count. And weight expression. So we are calculating the weight. For each and every link representation, we have to define the weight link. So weight link is defined by 1. So this is nothing but weight expression parallel WA plus WB. Series means WA into WB. Loop means sigma I is equals to 0 to n WA. Whatever the weight is to be calculated, WA, WB, WC or whatever. So this is the common rules like parallel, series and loop. Parallel means addition, series means multiplication, loop means defining star like a power n or a star. So this is an arithmetic rules. So now we'll see the parallel rule. is explained as term in first expression is summed with each term in the second expression. If the weight links of WA and WB, then result is WA plus WB. So example is nothing but, so if you take, this is the flow graph, 1 and 2 are entry node and exit node. So this is a parallel link. 3 to 4 is a parallel link, 3 is same for the 4, the input, 2 input links. So those 2 links are parallel links. So what is the rule means, we want to define WA plus WB or A plus B. So adding should be done, 0.1 plus 0.05. After applying the parallel rule, so this is nothing but, this is the flow graph we are obtaining. Like 3 to 4, the parallel link, removing the parallel link and direct link will be assigned, and value is 0.15. 0.1 plus 0.5, 0.05 is equal to 0.15. So this is the parallel rule. Same as series rule. So here the only vice versa. There we perform adding. Here we will perform the multiplication. Like if WA and WB are weights, then the result is WA into WB. So example diagram, this is the example diagram, flow graph. So this is the series rule, 3 to 4 and 4 to 5, 0.1 into 0.2. So is equals to 0.02. So this is the maximum path count arithmetic rules to be followed, common rules. Again, next we'll go for loop rule. What is meant by loop rule is considering the number of times the path is repeated. So here I am just assuming that this is the loop in this flow graph. Just I am assuming that there is a loop rule can be defined number of ways. So this is the first rule. So sorry, this is the first loop, second loop, 3 or 3 or 4 loops, whatever our wish. So here I am taking the 3 loops, like 3 times the loop is repeated. So 1 power 0, 1 power 1, 1 square, and WA. So this is the weight link A, and weight is represented as 1 for every link. So 1 power 0, 1 power 1, 1 square. So 3 times loop will be repeated. So 1 plus 1 plus 1 is equals to 3. So this is the 3 is a self loop, 0 to 0, 1, 2. So 1 star 1. So that is the 3. This is the flow graph we are obtaining when the loop rule is defined. If there is any self loop founded, remove that self loop and defining the flow graph. So this is the loop rule. Next, coming to the here, how the maximum path count is achieved, how the arithmetic rules, nothing but parallel, series and loop rule is applied on the particular example. We will see in this example. So I am taking here the flow graph consists of, this is the entry node and this is the exit node, and these are all the paths which defines the link representations like A, B, C, D, E, F, G, H, I, whatever. So and it consists of direct links, and there is a series links and parallel links and loops. Loops also. These are all the parallel links and this is the loop. We can say this is the loop. So all consists of this example. This flow graph consists of parallel links, series, serial links and loops. So now we'll define the first application is maximum path count. So see this, for the first step we have to define, for every link we have to define the weights. So for weight means I already told you that for every link weight is equals to 1. So place one value for all the link representation. In the place of A1, in the place of B1, in the place of C1, D1, E1. So all places. So where there is a loop, I am just assuming that there is a 3 times loops will be repeated. 4 times. 0 to 3. 0, 1, 2, 3. So 4 times loop will be repeated. This loop. So that's why I placed some loop way. And next here, that is nothing but 4 to 4. 4 to 4 means this is a self loop which defines serial loop. This is the serial loop. 1, 2, 3, 4. This is the 4. Means 4 times the loops will be repeated or self loop will be defined. So the assume weights to each link. So this is the first step to be followed. So next one, see, all parallel loops are reduced by applying parallel rule. So here there is a parallel rules. Nothing but parallel means adding. So if there is any parallel link, all links can be added. So in the previous flow graph, there is the 2 links are parallel, 1 plus 1, 2. And here also 2 links are parallel like this. So 1 plus 1, 2. So rest of all is same. Applying parallel rule to flow graph. So next one, if there is any serial links are combined, applying serial links. So see this 1 into 2 into 1, 2. Again, this is the why, because we didn't remove this. Why? Because it has loops. So next, in the next flow graph, we are going to remove the loops. So this is the series rule. Series rule. When we apply the series rule on this flow graph, so this is the flow graph obtained from this flow graph. So this is the flow graph. Next, from that flow graph, reducing the inner loop. So 0 to 3, that is nothing but inner loop. 4 into 1 1 power 0, how we can return the 4 means 1 power 0, 1 power 1, 1 square, 1 cube. And this is common as 4 into, 4 to 4. So 4 can be written as like this, 1 plus 1 plus 1 plus 1. 1 plus 1, 2, 2 plus 1, 3, 3 plus 1 is 4. So 4 times the inner loop will be repeated. So I am writing this 4 as in this way. So this is nothing but reducing inner loop. So next, from this, again 4 can be written like this, and this is the 4. So this is the from this combining serial links like 1 into 4 into 1, so 4. So this is the 4 to 4, and again we got the loop here, and that loop defines like 4 into 2, 4 into 2, 8. This is the loop means star 8. So 8 power 4 will be defined. This is the first, we have to define the serial link. 4 into 2. Serial means multiplication will done. 4 into 2. So there the self loop will be achieved, like 4 into 2 means 8. Self loop will be achieved. So for that self loop, there is a by removing the self loop, reducing the self loop, a star will be placed. A is equals to 8 and star means 4. So 8 power 4. So then this is the flow graph, reduced flow graph, and we obtain the flow graph is 2 into 8 power 4 into 4. So calculate that value. 2 into 8 power 4, 8 into 8 into 8 into 8. So into 4, 32,768 maximum paths we have achieved from the starting flow graph. What we have taken the example. So this is about the maximum path count. So see this is another alternative way to calculate the maximum paths by substituting corresponding weight of each link in the path expression. So this is one. So what I taken the example as a first flow graph. So all the weight links are defined, and from that weight links, loop will be 3 times. I assuming that inner loop is 3 and outer loop is 4. So 1 cube means 4 I have written like 1 cube, 1 power 0, 1 power 1, 1 2, 1 cube, and this is the way to define. So this is all 32,768 maximum paths can be achieved by the flow graph what we have taken as an example. So this is about the maximum path count of node reduction algorithm, and this is the one of the application which follows by the node reduction algorithm. So hope you all understand about this algorithm, and thank you. So next application will go.